Hey, good morning, Igor. Can you hear me? Francesco, are you able to hear my audio?
Yes.
Woohoo! Okay, what I'm gonna do, this is the first time we have used Zoom, so I've got a feeling that probably a lot of people are gonna be on the GoToMeeting call, so I'm gonna drop in like maybe 2 minutes and then see if I can wrangle them back into this meeting.
Yeah, I was on the GoToMeeting and it's waiting for GTM line 11, which is
Okay.
probably.
Yeah, let me go hop over there and I'll be right back. I'm gonna see if I can get that started, and that way, if other people are waiting here, we can get everybody in the right place.
Yeah. Hello.
So then is in a GoToMeeting trying to get people over here.
Hey, Anlin. Hey, Igor.
Good morning.
Morning. Nice to meet you again.
Yeah.
Hey, Anlin. Francisco, me and you, Anlin, were in the same team.
Aha, nice.
Yeah, according to Dan.
Nice to meet you, Wenling.
Yeah, nice to meet you too. How's going?
Good, thanks.
Yeah, Francisco is keeping me busy.
Everyone, I wasn't actually able to get into the other meeting. It looks like our credential no longer works, so we're gonna have to just wing it. And then what I'll do is I'll send out an announcement again, just to remind folks that we're now in Zoom and not any longer in GoToMeeting.
Okay, thank you.
It's good to see you again. I haven't seen your face in a while.
Yeah, it's exactly a year. Yesterday was my anniversary.
Oh,
Nice to meet you.
congratulations.
Yeah, thank you. Yep. Sounds like we have a agenda today.
Yeah, I think what's going to happen is Adrian is out today, Paul's out today, Vincent's out today. And then the other challenge is I think probably a lot of people are in the other conference. And it looks like the password no longer exists or is working to start that meeting. I think probably the OCP folks have shut that one down.
I
So
see.
it may take a while for folks to kind of migrate over to the other side. It looks like Marcos found us though, so that's good. Let me go ahead and open up the agenda here, and I'll do my best to substitute for Adrian while he's out of the office here for us. Got some new folks on the call today. I'm going to give them a chance to go through and introduce themselves. Okay, I've got the agenda up here. Let me see how I present on GoToMeeting.
On Zoom.
Here, where is share screen on this thing here? Actually, it's got to be here. Share screen. There we go. Okay, is everybody able to see my shared tab here?
Yes.
Okay, fantastic. First off, we've got some new folks on the call. Satish, you and I know each other, but I don't know if everybody knows you. If you want to introduce yourself real quick.
Sure. Yeah. So I'm Satish, and I joined Meta a year ago, and I'm currently working on a team called RTP, Release to Production, where my primary focus is on the NPI side of things. So we see ourselves as like a funnel where we gather things across hardware, software, firmware, manufacturing, data center, and just put together a system and validate it before we go and say, okay, let's go live and start using for production traffic. It's more of a hardware validation, but at the system level and the rack level.
Okay, fantastic. Sounds like you fit right into what it is that we're trying to accomplish.
Yes, exactly. I was missing the coding portion of it, and that's why I found Francisco working on this lane margining tool. I just right away jumped in and started doing some coding.
Oh, fantastic. Francisco, did you
Yeah,
want to introduce yourself?
I'm part of the sustaining team responsible for the hardware in the fleet. And I come from semiconductor industry, always working on some sort of SerDes, Ethernet, long haul communication, forward error correction.
Mhm.
I have been at Meta for 4 years. On the first week, I wrote we should be looking at signal integrity at PCIe level in a more analog way. And 4 years later, it's actually starting to happen. And that's this lane margining tool. I do have the original document I had written when I joined the company. So I'm happy that this is finally happening.
Okay, yeah, it would actually be really interesting to maybe deep dive into the topic of PCIe in general, right? Because I think as more and more focus on this area as PCIe speeds continue to increase, and we run into more and more weird edge cases and things for SI, right?
So I do have, if we can get to it today or next week, a brief presentation of what we're working on, what we're trying to do. We are trying to open source this tool, so it would be good to maybe have a 5 minutes or 10 minutes presentation on that.
Yeah, I think we can do that. Let's get through the rest of the introductions, and then what we'll do is we'll jump into the agenda that we had standing. I think a lot of the discussion that we had planned, we probably won't be able to have without the right folks here. So we might be able to go ahead and jump to that a little bit more quickly. Real quick, we've got Leland, if you want to introduce yourself. And did I pronounce your name properly?
Oh, yes, thanks. I joined Meta last October, so I'm still pretty new to Meta, and I'm work as a system integration engineer in the data center operation. So we are trying to get that fleet health management, especially on the PCIe data path. That's why I'm working with Francisco very closely and Satish to get this LMT done. And also before joining Meta, I worked with Francisco for quite a while, doing some service tuning related work.
Cool. Well, welcome. We're super glad to have you guys. The normal crowd's not here, unfortunately. They're still stuck in the other meeting, but I'm sure we'll get everybody together next week. I didn't anticipate that our password would be turned off already. So that's unfortunate. We had a couple, well, actually, let me introduce myself because I don't know all of you as well. My name is Dan Frame. I work primarily with Adrian and Paul on the Meta side, and we've been sort of chairing this committee. We started it, goodness, I guess it's been about 3 years ago. It's hard to believe, but it has been. And really what our goal was we wanted to create the ability to share sort of common diagnostics and tools that we felt were non-differentiating, right? Like areas where we don't necessarily compete with each other, but we have shared interests, right? PCIe is a great example of that, right? It's not core to any of our missions, but it's sort of, a fundamental tool that we all need to use, right? Anyway, what we did was we had taken a framework that we were using internally, which we called Melton, and we'd put that together at Google primarily to allow us to share our test more easily with outside folks, right? Prior to that, we had this big, giant, like all-inclusive blob of stuff where like the test executive and the diags and the frameworks to execute them and the way they collect data and everything else was all very, very tightly coupled together. We called that voodoo, ironically, and there was a lot of voodoo behind it, but it made sharing these things impossible. So we're very interested in being able to, share diagnostics between our manufacturing partners, between our design partners, our data centers, our validation labs, our outside compliance labs in the cases where we need to do that, like if we've got colos or shared facilities and things like that, where we need to do things above and beyond what we would normally do in our data centers. We wanted to be able to make those things portable. One of the key principles that we adhered to is we did not want to try to force a particular test executive or framework on anyone because we felt that that was just too varied, right? Instead, what we tried to do was come up with a shared input format and a shared or common export format for diagnostics. That became the OCP test and validation output specification. It's quite a bit different from what we started with. And now I would say in the last year or so, we've been working on porting diagnostics over to that framework and then providing the external versions of the framework to provide that output format. So we have created a C++ version of that, which is something that we use internally. Adrian at Meta has created a pure Python implementation. And then we're also coming up with some Python bindings where you can use our C++ implementation from Python as well. But the good news is, regardless of which library you use, the output looks exactly the same, right? You can kind of consume that from any different test executive. If you go through our shared drive, I'll share that with you guys in a minute in case you don't know where that's at. You can see basically all the iterations and things that we went through, and you can read some of the previous, or the videos are up there as well. Some of the previous documentation we put together about why we chose this particular path and the sort of thinking and reasoning that drove that output format that we were looking for. Where we're at the moment is we've got 3 diagnostics that we're working on for our first batch, which we are looking at core diagnostics right now. So we've got sort of a CPU memory test, right? We've got the bus test, which is basically just PCIe for now. We have a shared MLC test for sort of like QPI links and things like that between processors to also augment the signal integrity. Then we have our SAT diagnostic, which is sort of a generalized stress test for compute and storage, right? And then finally, there's one other one that I'm missing. What is it? We said SAT, we said MEM tester, we said PCIe. Oh, we have another, yeah, FIO, right? We've got the storage-based disks or storage-based test for disk. And then the other one that it looks like we're going to do as well is a partnership with one of our CPU vendors. You can probably guess who that is, but that will be for a silent data corruption diag that we're probably going to open source in this format as well, that we found particularly helpful for us. So that's kind of a summary of where we're at right now. If I went through the agenda that we had today, we were going to talk about some of the input and output parameters for PCIe crawler, which is a tool also from Meta that's sort of in your space. So I'll be interested in hearing a little bit, Francisco, about the differences between the 2 tools, right?
Yeah.
Paul's with this, so I'll probably skip on that one today. And then the other item that Adrian kind of put together for us here was a quick start for new folks. If you're able to see my new tab, this is all in the drive as well. I don't know if you guys have had a chance to check this out, but this is sort of a synopsis of all the other presentations that we have out there, right? And I think the final part of this, sorry to be so long-winded, that I haven't touched on is we ultimately want to use all this data for something, right? And that's for characterizing parts. And then internally at Google, we've been working with a third party to kind of take this data and use it for repair prediction, right? So basically we go in, we run all these different tests, we get all this great numerical data and symptom level data, and then we use that for basically inferring repair prediction based on historically successful repairs. As our machines have gotten larger and more interconnections between them, not surprisingly, it's gotten harder to fix them, both for manufacturing and the data center. So that's another goal that we've got for the project as well. So at that point, let me stop and see if there's any questions about those topics.
Yes, one quick thing I have is, sorry, Francisco. Then regarding the availability of these tools for Meta to use, do we have the test executables as well, or it's just the structure so that we can fit in any in-house tool with it?
So it's both, right? So we have the core libraries as well as the spec published, right? If somebody wanted to make, you know, a different implementation of the spec, like in a language that we don't support, like C# was one that came up quite frequently, right? You know, well, we're kind of a Golang, C++, Python shop, right? But we did get lots of folks, particularly on the equipment vendor side, that were interested in C# and some of the Microsoft technologies. That would be an area where you could use our validators, our JSON schema tests, and things like that to prove like you have implemented the spec properly. In addition to that, though, we're also going to put all the diags up there, and all of them we want to be open source. We think, you know, in the hyperscaler space, it'll be very hard to get traction with anything that's a binary, right? That being said, there's a few things that just are that way and it's unavoidable. Like for instance, if we had a GPU diagnostic, it probably does depend on maybe libcuda or another library where it's sort of like it's a shared object, right? We have the headers, but we don't necessarily have the implementation. And that we think there's just no real way around that, right? There's going to be lots of things that kind of fit into that category.
Makes sense. Okay, thanks, Francisco.
Yeah, you were asking about PCIe crawler, and I think that that is a tool that has been released some time ago from Meta, and I think that it has served its purpose for a while. And I think that now we are actually feeling somewhat the need of some feature enhancement. I think the most important one that we are seeing in our fleet is the fact that PCIe crawler uses a cached version of the PCIe config space. And what we are seeing is that when we have some switches that are using virtual BDF implementation to keep the BDF in the same spot. And these two things put together end up with the unintended consequence of having a config space that remembers a little bit of stuff, forgets a little bit of stuff. So PCI crawler ends up giving you information that do look like a device is there. But if you really look into it, the config space is actually gone. So only some of the things that have not been overwritten in the cache are remaining there, and therefore it seems like a device is there, but it's not there. So we originally had that with a cache implementation because it's expensive in terms of bandwidth to go in and every time fetch all the config space from PCIe. Right. But I think at this point, we need to figure out how to kind of balance that with the fact that whenever a device is going away, we can actually see it. In the past, it wasn't as big of a problem because these virtual BDFs trying to keep the spot did not exist. And therefore, it was all or nothing. Things were moving around, and that's the way we would figure out that something was wrong and stuff like that.
Okay, and then the specific problem that you're looking to correct here is like if we've had a device that's fallen off the bus for whatever reason, right? It's still going to appear that it's on there, right? Even though the device has gone off into la la land, right?
Yeah.
I think we've also seen that same issue with the AER error counters and things like that, where you're grabbing a stale copy of them, right?
Yeah.
Yeah. Okay. Since we've got a small audience, we kind of have a luxury that we can probably talk a little bit more than we normally would. If you guys have your presentation that you would like to present on some of the new PCIe tools that you've got, now would be a great time.
Okay.
Before
So
we go there, one quick thing, sorry if I'm just plugging, and then I think internally what we see is like there is an increased interest in getting into Rust. Yeah, so the general recommendation, like if you're coming up with a new tool, start with Rust and see if you can accomplish what you need to do. Otherwise, yeah, Python will be the default preference. But there is a push internally to see if we can. So if there is a plan, we can add Rust to this committee and see what we can do with it. Just
Yeah,
FYI.
so we have a interest for Rust as well. Let me actually dig into that topic a little bit, right? So one of the differences right now between the Google C++ implementation, and I'll touch on why it's C++ as well, right? Is that what we've open sourced, like on the Meta Python side right now, is essentially only the library that allows you to generate the output, right? So if I go through and I remember Adrian's code, effectively what it's doing is it's got a bunch of Python data classes, right? And then he's got all the sort of helper methods and creature comforts to go and generate, you know, our measurements and our hardware info and all those other things, right? Now, like, it's important to have that code standardized because it's how we make sure that we always get the same output, but it's not a ton of code when you really get down to it, right? The biggest thing that we have on the Google side that we were like, we can't re-implement this in multiple languages, right? Is what we call the hardware interface layer. Satish, you probably know this as sort of like Jesus back in your old history, right? We're not using Jesus any longer, right? But it's sort of like it's along those same lines. For the folks that aren't familiar with that, you can kind of think of it as like device manager for Linux, I guess, is the way that I would draw the parallel with the Windows world. It's sort of something that knows about all the hardware and, in fact, even some of the software in the system, right? Well, this is actually it's a ton of code, right? And it gets updated fairly frequently. So the reason why we implemented that in C++ is because we could do language bindings off to other places, right? We were thinking, obviously, Python and Golang for us, right? Although I think internally we're not using Golang as much as we used to, right? I think we're starting to move back to the C++ world. And then in our firmware areas, I think there's a bit more interest in Rust, right? I've read the Rust book. I haven't actually written anything in Rust. I happened to read it when I was on vacation, actually, which is kind of sad. But that's what I did. So yeah, I think, you know, this is an area where we could go from Rust to C++ bindings, and we could probably pull that in. But right now we don't have a Rust implementation to generate the output. But, you know, it's kind of, I wouldn't say it's trivial, but it's not a huge lift, right? I think that would probably be a weekend project or something, you know, at most, to probably be able to get that output.
Sounds good. All right.
Yeah, I think having all the common validators and things too, like which is work that Adrian had done, has actually served us really, really well, because now we can kind of have an alternative implementation with some amount of confidence that it is compliant. Now, at some point, we're going to make a change to that. We've actually got a change control process now. And when we get around to actually making our first change, when we have to change multiple implementations, that's where I'm scared that, you know, all these forks kind of come back to bite us a little bit.
That's right. Sounds good. All right, let's go started.
So I think that you have to unshare before I can share.
Oh, sorry about that. I didn't realize I was sharing. Did that stop it or not yet?
Yeah.
Yes.
I think this works. Does this work?
Yeah.
Yep. Looks great.
Perfect. So what we're going to present is what is PCIe LMT, and we'll start from what is LMT. So LMT is something that was defined in PCI SIG specification 4.0 and up. And it was an attempt to standardize a way to figure out what is the margin that the service receiver observes. And the margin is how much noise can I add on the left side, on the right side, on the top side, on the bottom side, before I start seeing that my 0 becomes a 1 or my 1 becomes a 0. And the more margin you have, the more unlikely it is that you're going to see a bit flip due to signal integrity. So what the PCI SIG did was to specify multiple ways to get this margin. The most interesting one, and one that the industry is trying to get implemented in many of the devices, is a non-disruptive way of getting this data out of the device. And
Francisco, can I ask a quick question? Forgive my ignorance. For the noise that you're talking about here, is it electrical noise on the bus, or is it like timing noise, like jitter and wonder, or like playing with your extinction ratio, that type of stuff?
That's a very good question. So the lane margining tool is trying to figure out both, meaning that on the if you go on the X side, you are trying to figure out how much margin you have in the timing domain, which mostly is going to deal with your jitter, your wonder, and stuff like that. On the y-axis, the margin will be mostly defined by your voltage swing and whatever is the insertion loss between the transmit and the receiver, and any ISI that gets involved, which kind of plasters over your signal. So the smaller the signal, the less timing margin you would have anyway, because the crossing will happen sooner anyway.
Gotcha. So it looks like your diagram on the right here, you've got a reflection problem, you've got some capacitance problems, you've got jitter, you've got all kinds of things going on there then.
Exactly. So here on the left would be what would account for NI with a lot of margin. On the right is NI with the less margin. And what LMT is trying to do, especially in the case of an independent sampler, is I'm usually sampling the data sitting at the 0 point, pretty much in the middle of this eye, and putting a threshold at 0 and figuring out if the signal is above the threshold, is a 1. If the signal is below that threshold, it's a 0. So by having an independent sampler, I can move to the right of that center point and figure out if instead of being at the center, I were to sample a little bit on the right, would I still see a 0, or would I still see a 1 as it was sampled at the center? In the case of this good eye, I can move quite a bit all the way to here, and I would be sampling the same exact bit as I sent at the center of the eye. If I do the same experiment here at the center of the eye, then I move, let's say, 25% of the UI, and then I start bit flipping, because my noise now ends up allowing for the signal to be below the threshold when at the center of the eye was above the threshold. So the independent sampler allows me to actually get a view of what if I was sampling way on the right, way on the left. And the sampling of way on the left and way on the right is trying to say, if I had jitter, for example, that may be ping pong instead of at the center of the eye, let's say 20% of a UI on the left, 20% of the UI on the right, would that still allow me to see the correct bit? So by knowing that we sample the same bit on the left and on the right at a certain margin, we can practically say that we'd be perfectly good if we had noise up to that level. Once we start seeing error, we know where that transition of the margin is. Is that clear?
Very clear. Yeah, absolutely. Let me pause here and see if anybody else has any questions.
And there is a text from Marcos in the chat.
Yeah, I was asking, is this similar to like an EDM measurement, like error vector magnitude sort of thing? I come from an RF world, so that's looking at constellations and stuff, but I think
yeah, so
looking at some
if you're looking at a constellation, what would be in that case, your Gaussian noise would tell you how uncertain you are to have that 00 or 11 symbol being very close to the center of where you expect that to be. And the distance of the two centers and the Gaussian noise that you can add on top would give you a very similar results of this. So if you were to put all your samples and that would pretty much be a measurement of the distance between the closest samples that you have, and that would be your margin.
Yeah, I think maybe to augment Francisco's answer, when you're looking at the constellation diagram, Marcos, you're kind of looking at it from symbols and phase perspective, whereas the diagram here with the eye diagram, we're more looking at it in time and amplitude.
Yeah.
Excellent. Thank you. I'm just trying to make sure I can keep up. Thank you.
Oh yeah. No, it's a very good question. Sorry, I couldn't draw as good a parallels as Dan did. Any other question? So what we're building, what are we building? So we are building a tool that allows for a parallel collection of data. So PCI SIG has a tool in their folder that was originally written by Intel as a closed source tool, mostly to showcase the functionality as a demo tool. And you can use that today. It allows you to get a reading of the margining, but it only allows you to do one BDF at a time, one lane at a time, and you can only move one step of the margin at a time with a very set dwell time on each point. So if you want to go 20 steps to the right, 20 steps to the left, 20 steps on the top, 20 steps at the bottom, you would have to sit for a dwell time amount at each one of the steps. And there's really not a lot of value when you are in production to actually sit at step one. If you are going to have problems at step one, it's going to be a big problem anyway. Many times you will be sitting there and observing that there is no problem. So in a production system, what we'd like to be able to do is to do the parallel collection of data for multiple BDF for all the lanes all at once. And in general, we might, in some cases, only be interested to say, do we have at least 5 steps of margin on this interface? If we have more, we don't care. If we have much less, we don't care. What we might care is we want to have at least 5 steps of margin, or if we don't, we are going to do a maintenance whenever it's allowed, so that we don't start having problem while in production. And
Francisco, quick question. What was the definition of step again?
So the definition of step, if we go back here, would be each step that moves from the center of the eye. And so you can move a certain number of steps on the left, a certain number of steps on the right, and it allows you to say it will have a formula depending on the implementation that will give you an idea of how much percentage of a UI you have in terms of margin.
Okay, let me maybe ask my question a different way. I'm sorry, I still don't quite understand.
Yeah.
If I had a different data rate, like obviously my eye is going to be narrower, right?
Yeah.
Would there be the same number of steps in a faster data rate? Like, is there a number of steps between the two crossing points, or?
Yeah. So the steps will be implementation dependent. The translation into how much of a percentage of a unit interval, which is your period of, so dependent on the data rate, will depend on how many steps are in that implementation. But
Okay,
in
got it.
general, when we say step, ultimately what we care is the percentage of a unit interval, and that translation is just implementation dependent. So
Okay.
some device might have 10 step that gets you across the full period, and some device will have 20 step to get you across the whole period. And that's just an implementation detail. So ultimately what we would care is how much percentage of a UI do I have of margin? And for some devices, it might be 2 or 3 steps. For some devices, it might be 5 or 6 steps.
Gotcha. So it sounds like the step is basically the level of granularity that I can adjust the A to D controlling the sort of the left-right timing trigger of the bit sample.
Yeah, exactly. And
Okay.
it's left and right and top and bottom. And actually, usually you would have a more precise, much more, many more steps on the top and bottom, just because it's a little bit simpler to define the top and bottom, and then a little bit more coarse on the left and right.
Okay, thank you.
Yeah. So the other thing we wanted was a tool that allowed for collecting stuff only at a certain margin step. So as we said, in production, we might only want to say, we have this much percentage of your UI of margin, and that would be enough of an answer. When we are doing characterization or validation of a design of a new device, a new system, we might actually want to go step by step and figure out what is the distribution of our margin, as opposed to just saying a pass and fail criteria based on one set threshold. We wanted to build a tool that was open source. We believe, as you said then at the beginning, that there is not much to gain from everybody building their own tools in this space. I was totally surprised that there wasn't an open source tool to begin with. And I felt that it was important to seed something and then figure out where we would land from there. So, and we wanted this tool to be flexible enough that it can be used for service validation and characterization, ASIC validation and characterization, system level integration, validation characterization, and the diagnostic for low margin during production. Any question?
I still have a few questions, but I think you might get to it later in your slides, so I'll wait till the end. And
okay, so what we have here in this slide is the output that we are currently using. I actually have a cut and paste error. I will fix it later. Actually, let me try to fix it now. Sorry about that. So here, when we use this tool, what we are trying to tell on the input side is we want to collect the margin for this set of BDFs for all the lanes, and we want to know whether there are errors or no errors at step X, Y, and Z. And so here it's the set of output that the tool will give us on a per lane basis. It will spit this out in either JSON or CSV format, depending on an input parameter. In our world, we will also pipe this data to a table so that all our information reside in one place.
Okay, and are you invoking your tool right now from BIOS or from user space?
We run this from user space. It's requiring a set PCI. That's all the interaction with the PCIe devices is done through set PCI. So whatever is needed in your system to run a set PCI in terms of credential would be the only requirement to run this tool.
Got it. And then I guess when you're running the tool, it's basically it's resetting the PCI device and putting it in a training mode again. Is that right?
No, actually, this is a completely non-disruptive thing that uses that can be done in a production system. In fact, we have done this on tens of thousands of systems at this point while they were in production, and we just snuck in, got the data from this lane margining tool, and nobody noticed anything.
Okay, so then I guess when you're doing that, like in production, you're not actually changing the margin step. You're leaving it there at the 0 where it trained when the device booted, right?
So when this the lane margining can be implemented in two ways. One has an independent sampler and one does not. And so devices can decide whether they implement the independent sampler or they don't. So we found that a lot of these PCIe switches, a bunch of retimers, some CPUs, they implement the independent sampler. Some GPUs, some CPUs, they implement the non-independent sampler. In that case, it would be disruptive. So in that case, we would run that potentially only before and after a repair when the server is already out of production, or in any places where our processes can assure that we are not impacting a production workload. But in many, many cases, we can run this without disruption, and we can move the independent sampler, which ends up just doing a comparison with the current sampler and saying the current sampler is seeing a 0. Would I have seen a 0 as well if I set this much far away from the center? And that's the way it accounts for errors during the dwell time.
Okay, gotcha. That makes sense. And what is your tool implemented in right now? Is it Rust or?
So it's in Python. I only know Python. I started this tool, and then some people did say, "Oh, it would have been good if we did it in Rust." It still might be good to do it in Rust at some point. There's a lot of very, very bit level shuffling of things. All the commands to the PCIe are done through opcodes. The response is in a couple of bits of somewhere in the PCIe, and you have to decode all that stuff. So it's tedious implementation, but it's not rocket science.
Okay. Yeah, rocket science to prove it works, though.
Yeah, exactly. So I think, I mean, you nailed it there, that we wanted something to show that this can be a very useful tool, and we have been able to show that in our fleet. In fact, the next couple of slides are example of this thing running at scale. In this first example, what we wanted to show, these are two different systems that have similar devices, and what we wanted to check is that even though they were running different firmware in one of the retimers, we were getting consistent results on the two. And the system on the left and the system on the right have a different firmware in the retimer, but here we have a list of BDFs on each row. The first block here is one direction of the retimer. This other direction is the other direction of the retimer. In both cases, the receive side of the retimer. And then all the lanes are collapsed in this view. And on the columns, we have the steps for the left side of the timing, and then the steps for the right side of the timing. One interesting observation is that it seems a little bit lopsided, and the device ends up preferring the left side versus the right side. It's not super important because for the most part, it has a lot of margin anyway. On the right side, we have the new device running a different firmware. And what we wanted to make sure is that it ended up having about the same amount of margin. The extra beneficial information that can be found here is, if you look in the details, you will see that there's a little bit less margin for 4 lanes versus the other 4 lanes, 4 BDFs versus the other 4 BDFs. And the reality is that this is due to the fact that 4 GPUs are a little bit closer to the retimer than the other 4 GPUs. And therefore, there's more PCB to get to the retimer. It probably would be good in a system like this to be able to change the transmit settings for the GPUs that are a little bit further. And then we might actually end up having about the same margin for both. None of these seems like a big problem, but in the case it was a bigger problem, it would have prompted us to do that rather quickly. Otherwise, slowly but steadily, we are going to optimize and tune the settings for the TX of the GPU for the traces that have a longer PCB.
Okay. One question. It's a little hard for me to see your graphs here.
Yeah.
Are your columns the individual lanes, or are they the number of steps that you moved off from the point?
So on the rows are the different BDFs for the different GPUs on the board.
Okay.
On the columns is the different steps on the left and on the right. And the data we collected is per lane, but actually they are all collapsed into one row for all 16 lanes in this view, because in general, we wanted to look at an interface and not lane by lane, whether we had a problem or not. But
Okay. So
we do actually collect the data for lane by lane, and we do actually have views where we look at lane by lane to figure out if we have a lane bias or things like that.
Got you. So like in this particular example, would it be a correct assumption to say you have, what is it, maybe about 10 steps between your crossing points where you get in the danger area there?
Yeah, exactly. So
Okay.
perfect. And if we go and look at this device and the capabilities, we would see that it's about 6% per step, if I remember correctly. And therefore, that would give you about the UI level that you'd be able to have error-free.
Okay, this seems very, very cool. I mean, this is definitely along the lines of the types of tools that it is that we're looking for. I think that this definitely fits into one of the core sort of bus things that we're looking at. For LMT, refresh my memory. Did that come available in PCIe 4 or was it 5?
So it became available in 4, and I don't know why nobody really stepped up to the plate to actually make it super important. But it's part of people's language at this point. It's not completely foreign. There is going to be, I would say, a lot of education that needs to be done, but I don't think we start from scratch. And I think that 2 years ago, probably we would have had to start from scratch.
Okay, very cool. And then I imagine right now you've got support for at least AMD and Intel processors.
So we tested on both of them. In the case of CPUs, Intel, I think, is not an independent sampler. AMD, I don't remember. Leland, do you remember?
AMD doesn't have independent sampler either.
So neither the CPUs have an independent sampler. That's one of the things that I'm hoping we can push the industry to be more independent. Both of the PCIe switch vendors that we use do have independent sampler. The retimer that I think has been on everybody's board lately in some of the GPUs board has an independent sampler. The GPU does not have an independent sampler. The latest GPU, I think, doesn't have an independent sampler. A sampler, an LMT implementation yet. I think it's going to be a firmware enabled thing. It's a requirement from a PCIe standpoint. But it's not a requirement to be independent sampler. And when it's not independent sampler, what happens is that mostly you're going to see only the timing margin being supported. And that's going to be done by jittering the clock. And that's it.
Yeah, very cool. And then I imagine if you were to catch errors with Wonder, you would just have to get lucky and get it like sampling for a long enough amount of time to start to see that to impact it, right?
Yeah, exactly. So this we would run. I mean, the idea is to run the diagnostic portion, which is saying we see at least this much margin on this interface fairly regularly, let's say once an hour, and then have a little bit more in-depth runs less frequently on devices that are probably more prone to errors than others, since we're going to do it in repairs and stuff like that.
Yeah, let me ask you a question.
Yeah.
When you were going in and doing some of your initial analysis of the data that you got back, are you able to see like you would assume that there's a very strong correlation between like a low margin and the presence of AER errors? I imagine you guys do see that, right?
Yeah, we do see that. We see a receiver error without the presence of traffic, and then we see bad TLP and bad DLLP when there is traffic. We are also trying to correlate that with the parity and the lane error. We are not yet making good use of that extra information, and that would probably be something that comes along for the ride, maybe as part of this LMT tool or as part of the tool set around PCIe. Maybe in the same code base where we would get the information about the parity and from the skip order set and the lane error. Lane error and parity order set are both things that would allow to know what lane might create errors. And in the case of the skip order set, also to discriminate between is this problem happening from X to the retimer or from the retimer to Y. And that would be important information. The margining tool would be able to give a similar information, but the parity would corroborate that that's in fact what we are seeing.
Very, very cool. No, I think this is super useful. I think next steps for us is I'm going to get with our PCIe folks and let them know about it. If you guys could send me a link to your presentation, it looks like this was intended to be at the OCP Global Summit. This was maybe the presentation that didn't get accepted for whatever reason, right?
Yeah,
We
I
can-
think we submitted for the wrong place, but I think so. I'll put this in a Google Doc presentation and then send it over.
Well, I think what we could probably do is we can include it in one of the demos that we have planned with HP and Arun. They're working on several things here, and we could possibly highlight this one as one of them. I need to find out that the devices they have, though, because they're older OCP servers, but I suspect that they are at least Gen 4, but I need to validate that, right, to make sure that's going to work. So I'll get with her and find that out. Send me a link to your presentation. And is there a place where we can go and look at the tool yet, or is it still not up for open source?
I think so. We got all the approval and everything, and I think between within a couple of weeks we should be able to get that uploaded to the GitHub.
Okay, and are you looking to upload that to Meta's GitHub or OCP's GitHub?
Meta's GitHub.
Okay, so for it to be an OCP contribution, I think they do want it to be up to the OCP GitHub, but we can work all that stuff out. Like it wouldn't be the first thing that's not there, right? Awesome. Hey, we ran out of time because it was an interesting conversation. I apologize, Marcos. You had a slot to talk about setting limits for diagnostics. Is it okay if we go through that next time?
Oh yeah, I'm actually traveling, so I'm that's not going to be ready for a bit. So
okay, perfect then. Then I felt bad because I was like, oh, we're not going to get to this. So it sounds like
no,
you're not out.
No,
okay.
I'm dialing in from Mendoza, Argentina right now.
Oh, fantastic.
Wow.
Well, safe travels, my friend.
Nice.
Okay, well,
Cool.
thanks everybody. Send me over the link to the presentation. I'll get it linked to the notes, and then Adrian will have to drop it into the folder. Unfortunately, I'm not able to do it right now for reasons.
All right, very good. Oh, thanks a lot.
Yeah, thank you guys very much. Thank you so much for sharing your tool with us. It definitely looks very interesting.
All right, very good. Thank you.
Happy Wednesday, everybody.
Yeah. Thank you. Bye.
Bye-bye.